Ladies and gentlemen, Mr. Brescher here. Today, by the end of class, we are all going to be able to evaluate algebraic expressions with one variable and with multiple variables when we're given the value for each variable. We're really focusing on our algebra and functions standard 6.3, which is to define and use multiple variables when writing expressions to represent real-world and other mathematical problems and evaluate them for given values. Let's move on. First, we need to take a look at some vocabulary terms. Here we can see algebraic expression, and there's an example above, n minus 6 plus k. An expression with one or more variables. That's called an algebraic expression. Okay, next we have a numerical expression. You've probably solved a few of these while working on order of operations. This is a mathematical phrase with only numbers and symbols. Okay, and we're going to talk a little bit about the difference between an expression and an equation as well. But next we have a variable, and a variable is a symbol that can represent one or more numbers. Usually it's a letter like X or Y, but it could really be anything. It could be a picture if you wanted it to be. In math, it's usually a letter like X or Y. And finally, we have to evaluate, and this is basically just to simplify something to lowest terms or to solve something. Let's take a look at this. Here we have a balance beam, and it is perfectly balanced, which means that both sides are equal. This would be a type of equation that we could write whenever there's an equal sign. But if we just focused on one side, and we knew that the apple was equal to 18 grams, okay, we could solve for the total weight of the apple plus our little gram piece here. Okay, and the total would be, we would just replace the A with the value of the apple, which is 18 grams. So in all, we would end up having 23 grams. And you can see in the equation, whenever we actually solve this problem, that over on this side, we have 23 grams. Okay, let's move on to look at some more expressions that's without the equal sign. Here we have a t-chart. I want you to make a t-chart in your notes, and let's see if we can put the algebraic expressions under algebraic and the numerical expressions under numerical. Okay, pause the screen and then unpause it, and we'll see how you did. Okay, you ready to see how you did? Let's move them over. This would be an algebraic expression because it contains one or more variables. Here's another algebraic expression. Again, it contains one or more variables. Next, we have a numerical expression. And if you were solving this, yes, you would have to use GEMDOS, order of operations. And we have another one, again, another good one in which you would have to use GEMDOS. Graciously excuse my dear Aunt Sally in order to solve that one. This one, yes, it has a variable. Actually, it has two of them, so it's algebraic. And the final one also has two variables, so that's an algebraic expression. Again, since they don't have an equal sign, they are expressions, not equations. Let's move on. Now we get a chance to see how this might apply to the real world. Try to evaluate the algebraic expression. If one pizza costs $12.56, we could say that P for pizza equals $12.56. So evaluate the cost of two pizzas. That would be 2P, or 2 times P. Pause the screen and then we'll check over and see how you did. Okay, let's solve this one together. That is the time sign. Notice we use a dot. We also used parentheses earlier. If we ever see the variable right next to a number, that means to multiply. Why do you think we don't use this little x while we're doing algebra? Why do you think maybe that we would use a dot instead of that? Excellent. If we use the x, it might be confused for a variable. So we want to get rid of that and use the dot. 2 times $12.56. And I'm going to pause the screen. Okay, how did you do? $25.12. Hopefully you remembered when we multiply decimals, we can't just bring it straight down. We need to count the number of decimal places in each factor. Try to do this one. See if you can work on, if you had a coupon for $5 off any purchase. Write an algebraic expression and evaluate. Go ahead and pause the screen, and then we'll go over it. Okay, let's check it out. If you wrote an algebraic expression, you would have to write, again, we would write 2 times p. You could put a dot or just write the variable right next to it. That means to multiply. And then we would put minus $5. Okay, now plug in the value for p and try to solve. What did you come up with? It should have been $20.12. Okay, let's move on to the next problem. Here we go. Now we have some practice. I want you to try to practice plugging in the value of the variable to solve each algebraic expression. Okay, so what did you get for the first one? That's right, if you plug the value of 3 in for s, we get 7 plus 3, and the answer would be 10. Here are some more for you to try. Again, take the time to write this in your notes, and make sure you're plugging in the value for the variable. So we would actually replace the y here, replace that with its value, which is 20. Don't forget order of operations. We need to multiply first. So we would have 12, and when we do 20 minus 12, we'd get the answer 8 when we evaluate. All right, I have a few more practice ones for you to do. Again, pause the screen, work those out, and then compare with a neighbor before you unpause the screen. Okay, this last one. I want you to try to come up with your own expression and value for the variable, and then evaluate. Or have your friend evaluate. Let's move on. Here's a great example of how we might see using an expression and variables or an algebraic expression to solve a real-world problem. The Patoka Marina has a rental fee for kayaks. It's $5 plus $2.50 for each hour. Okay? You use the chart, or you can even make a chart of your own, to help evaluate for each different amount of time. Then think about it. If you have $20, what is the most number of hours you could rent a kayak? Again, make the chart on your own, pause the screen, and then we'll go over it. Let's check out and see how you did. For 1 hour, we would have the $4 plus $2.50 times h. Well, h is 1. 4 plus $2.50 is $6.50. for 2 hours. Now it's going to be a little bit more challenging because we're going to have to multiply that 2.5 or $2.50 times 2, which is $5 plus $4 is equal to $9 for 2 hours. I'll go ahead and let you do the rest of them, but I'll give you the answers. And each one of these we could find simply by plugging in the value for the variable and then evaluating that expression. So what do you think? If you had $20, what's the most number of hours you could rent a kayak? That's right. 6 hours would be the most. After that, you would run out of money, or you wouldn't have enough for the next hour. Okay, well, I hope this helped you out. See ya.